Now we have learned about all the fundamental concepts of blockchain. Now let us learn how blockchain works. What is blockchain? A blockchain is a immutable ledger, which means when you add some data to the blockchain, the data can never ever be altered or it cannot even be deleted. So it becomes an immutable ledger, and this ledger is also decentralized. What do you mean by decentralized? There is no one single server. So when there is no one single server to save the blockchain or this entire ledger, there will not be any problem of single point of failure. So the copy of the ledger will be available with all the machines that are in the network. And it is a peer-to-peer network. So blockchain is a peer-to-peer network, which means the data transfer happens only between the peers. So there is no client server communication at all. So there is no central server. And of course, the blockchain is very, very secure. How it is secure? When you store some information in the blockchain, it is secure through some cryptographic functions or cryptographic algorithms. Say there are some hashing algorithms and encryptions are used. So the entire blockchain is completely secure. Also, it is very, very transparent. Since it is a peer-to-peer network, the data can be viewed by anyone who has authority to view the data. Each and every computer, they are called as nodes. So if you join with the laptop into the blockchain, then your laptop will become a node. When you have a very powerful supercomputer or even a quantum computer, then that becomes a node in the blockchain. So any system that has a very, very minimal processing power and which has a very, very high processing power, both can be part of the blockchain. So now, leaving out the types of the nodes, let us concentrate on how the blockchain works. Each node in the blockchain will have something called as a memory pool, and each node will be having the set of blocks which is called as a blockchain. So the copy of the blockchain will be available with all the nodes in the entire network. What is this memory pool or this mempool? Any transaction that is happening will be stored in the mempool. Let us see what are the steps that will happen. When a new node adds itself to the blockchain network, this new node will be communicating with any one of the peer or multiple peers to get the copy of all the blocks in the blockchain. Since every node will have its own copy of the blockchain, any one of the node will send all the blocks. So this node will finally get the copy of the blockchain, and this node will also become part of the entire network. What is mining? So mining was the first ever process that's been created by Satoshi Nakamoto when he created the cryptocurrency Bitcoin. This process involved some kind of processing power, or we can say any node that joins the network as a miner will be spending some amount of energy and the power to check whether all the transactions in the block is correct, and finally it will be adding that block to the blockchain. We'll see that in detail. This mining is understanding mining is very important because mining was a first process which is also called as a proof of work, and right now Ethereum has moved on to the new process which is not mining, it just moved on to validating. So we'll be learning about mining and also validating in detail. In this video we will be confining our explanation to mining alone. Each node in the blockchain network will have memory pool, or we can call it as mempool, and all the transactions will get stored in the blockchain as individual blocks. How do we get this block? So there is an intermediate process which is happening, and that process is what called as mining. So the miner will be selecting some set of transactions from the memory pool, and that will be formed into a new block which is called as a candidate block. This block is not yet added to the blockchain network. This block is still in the memory of the miner or the mining node. How mining works? So what is mining? Mining is something like, finding a treasure. When we mine the gold, we try to find the gold. But here, mining what really means is actually we find a key to the locker. So what is that key to the locker? We'll see in detail. Each and every miner in the entire network will try to guess a value. And that value is something like a value in the locker. A locker is having a value. We do not know what is a value. Each person will try to, or each thief will be trying to unlock this entire treasure box by guessing the value of this locker. Whomever guesses right will be getting the reward, or we can say whatever it is there in that treasure box will be rewarded to that particular person who unlocked that box. This is very similar to the mining process. What mining exactly is? Already we have learned about the Merkle root and also the previous block. This mining is a simple process where you will be finding the hash of this block. That is hash of this block header. And since this header contains the hash of all transactions as Merkle root, we can consider this hashing as for the entire block. This block hash will be checked against the target value. The target value will vary according to the current difficulty target, or we can say there will be a target which is set by the entire software or by the network itself. The primary objective of mining is you have to find the hash of the block, and the hash of the block should be less than the target value. Okay, or if every data is static, then how do we able to find a hash which is less than the target? Always a hash will be same, because we've learned that hash is a deterministic value. So when hash is a deterministic value, you cannot change it, right? Then how we are able to find out a hash value which is less than the target? You will get one hash and that hash cannot be changed. Here comes the usage of nonce. Let us understand the use of nonce with a demonstration. This is a demo blockchain in which we have got a demo block. This block is a first block. There is no data in the block, and you got a hash value. You could see the hash value, it has got number of zeros. These initial set of zeros or these preceding zeros, number of zeros is what called as a target. So you wanted to find a value which is starting with 4 zeros. That is the objective of the miner. Or we can say you wanted to mine a block in such a way that you get a final hash value which is equivalent to some value which is starting with 4 zeros. That will be the target. Right now the block is mined already. That is why it is in the green in color. Okay, all the values in the block is not changeable, but only one value, it can be changed by the miner, and that value is what called as a nonce, number used only once. So this nonce, right now it is 72,608. Let us assume I am adding some data. Say transaction 1 is getting added, transaction 2 is added. I've just added 2 transactions. When you look at the final hash, you could see the hash value doesn't start with 40. When it doesn't start with 40, then your block is not a proper block, or we can say the block is not mined properly. So what is mining? You wanted to change this nonce in such a way that the final hash value will be equivalent to something which starts with 4 zeros. So look at the value here. This mining process involves changing the nonce continuously and computing the hash, and you will check whether the hash is less than the target, that is whether it has 4 zeros. If it not, then you will change the next nonce value. So this nonce is a number which will be changed continuously till you find the value which starts with 40. If I click the button mine, now you could see the nonce has changed. So for this set of transaction, or we can say for this data, and for the rest of all the data, only the nonce can be changed. The nonce is changed to this number to get the hash. If I change nonce even to a single number, the final hash will change. So your objective is to find a hash value by changing this nonce continuously. So when you change this nonce continuously, and somewhere if you find a value which will lead to getting final hash with starting with 4 zeros, automatically this block is considered to be a mined block. This process is what called as mining. So guessing this nonce is the mining process. This involves a lot of computation work, because you guess one value and you calculate hash, you check whether it is starting with 40. If not, you guess a different value. And this is a continuous process. You will do it again and again. As we have seen in the demonstration, the mining is you find the nonce value and you find the block hash which is equivalent or less than the given target. Once if you find a particular hash value, then the miner has succeeded. When the miner has succeeded, then the mining is successful. What he will do is he'll be adding that block to his blockchain, and also he will be propagating that information to all the peers. Since it is a peer-to-peer network, each and every node will act as a recipient and also a transmitter, or we can say it will all be acting as a router. So this mined block will be propagated to all the nodes, and all the nodes will be updating with their blockchain with the new block. So what is the journey of a transaction? First, initially when anyone transfers, let us assume that Bitcoin is getting transferred from person A to person B. When the Bitcoin is getting transferred, that is called as a transaction. This will get added to unconfirmed transaction, which will be part of the mempool, and this transaction will be propagated to everyone in the network, and all the blocks will be all the nodes will be having this unconfirmed transaction. Now any miner or any node will select some set of transactions. These set of transactions will be combined together to form the candidate block, and finally the candidate block will be mined. When this mining process is successful, that is guessing the nonce or altering the nonce value in the entire block to get a hash value which is less than the difficulty target. Once the block is mined, now this block which is mined already with the correct nonce value will be broadcasted, and all the other nodes will be updating their blockchain with the new block. And now all the transactions that were part of the new block will be transferred from the state unconfirmed to confirmed transactions. So this is how the blockchain technology works. A transaction is requested by any person, and this transaction will be broadcasted to all the nodes, and it will get stored in the mempool. And now all the nodes or the set of miners will start to take the transactions from the mempool and they'll start validating. So in Bitcoin, the validation is mining, and with that we have seen the example, and every blockchain, it can have different algorithm to validate. So some kind of validation will be done, and all the verified transactions, or it could be a cryptocurrency transaction, or it can be a contract, or it can be a record, or it can be information, anything. So everything will be verified. Once this transaction is verified, all the transactions are combined, and a new block will be created, and this new block will be added to the existing blockchain, and now it becomes permanent and you cannot change it. So it becomes immutable, and once it has been added to the blockchain, only then the transaction will be termed complete, or we can say it will be changed into a confirmed transaction.